Have you ever wondered how a clock keeps time without any software? In this project, we have built a working clock purely from digital logic circuits, and we are excited to share the process with you. So, here is an overview of the topics we will be covering in this presentation. Before we begin, let me introduce to our team. We are a group of 3 students who collaborated on this digital clock project. Each member contributed to different aspects of the project, ensuring everything from the circuit design to final testing was handled efficiently. I am AbdullahZahid and I was responsible for the circuit designing. Along with me was Azam Khan who worked on the circuit testing while the M. Mohammed Ahmed was the one who implemented.
Assalamu alaikum. My name is Mohammedan and my fellow presenter Abdullah Zahid has given me the opportunity to speak about the project, the digital clock. First of all, I will tell you what a digital clock is. Basically, a digital clock is a type of clock that displays time digitally. In analog clock, the time is displayed by the different positions of rotating hands. The time in analog clock is always derived from some sort of pendulum or spring, and these pendulums were unable to be used on moving platforms such as ships as they release stored up tension. By the perfection of multi-vibrator chips, electrical circuit could effectively keep time under a wide range of conditions. As the time base had switched from mechanical to electrical, the time display had to follow the suit. Display devices called 7-segment displays were designed to allow the time to be shown numerically. So a total of 100 components were used in the project that consisted of different resistors and ICs. So the resistors were used to limit the current flow in the circuit, and a 555 timer IC was used to generate a 1 Hz clock pulse. A 4026 IC was used to power up our 7-segment displays, and 7411 IC is a 3-input AND gate. The project was a mixture of learning and fun. First of all, we used a 555 timer IC that generated a pulse at 1 Hz, and then the counter used and then the counter started counting from 0 to 60 seconds, and then from 0 to 60 minutes, and then from 0 to 24 hours. So this clock was a 24-hour format clock, and the result was displayed on the 7-segment display. In digital clock, a clock is a timing signal used to synchronize the operations of digital circuits, especially sequential circuits, for example, counters, registers, and flip-flop. So the principle of the digital clock looks that it provides a steady timing signal, generally a square wave that alternates at high and low voltages, and it synchronizes state changes. Components like flip-flops, counters, and registers only change state on a clock edge that could be either rising or falling. And it also controls the data flow, ensures that the data moves through a circuit in a predictable manner. Here are some problems that could be solved by using digital logic clock. The first problem is timing control in sequential circuits. As we know that in sequential circuit, the output depends on the input plus pass rate of the circuit. With control timing, it's very easy to know that when the data is read or written, and it keeps all the parts of the circuit in sync. Data stability can reduce mid operations that can reduce corrupt data. And a race condition occurs when a signal changes without coordination, which can lead to temporary glitches. So here's the Proteus simulation that we have implemented on the breadboard. Okay, so this is the Proteus simulation of the digital logic. We have used a 555 timer IC, and we took the reset of all the 4026 IC as common, and then we gave the clock to the first 4026 IC of seconds. And from this onwards, the output of the first 4026 IC is given to the BCD 7 segment display, and from this onwards the 1 Hz clock pulse is being transmitted to each of these 4026 ICs, through which the entire circuit is transmitting 1 Hz pulse at 1 second interval of time. And I can change the time manually by the use of these buttons, and I can also change the hours, but it won't reset to 0 until it reaches the 24:00:00 time. So that's it from my side. Thank you.
अब हमारे सर्किट कैसा काम करता है? सर्किट जो हमारा है वो तीन चीज़ों से कंसिस्ट किया हुआ है। फर्स्टली देयर इज़ अ 555 टाइमर जो कि हमारे पास 1 हर्ट्ज़ की रेट पर एक पल्स जनरेट करता है, जो कि हमारे काउंटर के अंदर जाता है, और जो हमारा काउंटर होता है वो मॉड 60 या मॉड 12 के ज़रिए जो है हमें सेकेंड्स, आवर्स या मिनट्स जनरेट करके देता है। और ये जो पल्स होता है ये हमारे पास जाता है 7 सेगमेंट डिस्प्ले के अंदर। अच्छा, अब इस टाइम को चेंज करने के लिए हमने एक पुश बटन लगा रखा है जो सबसे पहले सेकंड्स को चेंज करता है, और सेकंड्स के ज़रिए जो है हम मिनट्स को चेंज करते हैं। जो हमारा दूसरा बटन है वो क्या करता है, हमारे आवर्स को चेंज करता है थ्रू चेंजिंग द मिनट्स। अब हमारा जो सर्किट है वो सेकंड्स के ज़रिए मिनट्स चेंज करता है और मिनट्स के ज़रिए आवर्स चेंज करता है। क्योंकि हमारे आवर्स 12 आवर्स तक है हमने रखा है, तो उसके बाद जैसे ही 12 आवर्स होंगे तो उसके बाद काउंटर हमारा आवर्स का 00 तक पहुंच जाएगा। अच्छा, जिस तरह ही हमारा सेकंड्स 59 तक पहुंचेगा, अगला सेकंड हमारा 0 से स्टार्ट होगा। सिमिलरली जो हमारा मिनट 59 तक पहुंचेगा, अगला मिनट 0 से स्टार्ट करेगा। तो हमारे पास हम देख सकते हैं कि हमारा जो सर्किट है वो प्रॉपर्ली फंक्शन कर रहा है। So this was all about the digital logic design project for the clock. Thank you.